We're going to do mole ratio step next, NH4, NO3. And we decided to go here first, NaNO3 first. In this case, in this problem, does it matter which product we picked? No. We're going to have to eventually go to both of them, so it doesn't really make a difference. So we just picked one. So moles of NaNO3. And then last step will be to go to grams of that product. So get rid of moles of NaNO3 and go to grams. Okay, so moles gets the 1 here and here. This step is our mole ratio step. So moles of NH4 is 3 and moles of NaNO3 is also 3. And then we need the molar mass of each of these compounds.
Bottom left is
80. And then that one's 23 plus 14 plus 48. Thank you. Okay, so now I do the math, right? Multiply across the whole top, divide by the whole bottom. It's going to be pretty close to 30. Okay, so 31.9 grams of NaNO3. I want you to get into that habit of putting that label on the end so that we're really sure about what product it's going to. So does this yet answer any part of our question? Can we come down here and say our mass of sodium nitrate is 31.9?
No.
Not yet, because we don't know how much the other reactant will allow us to produce yet. So we need to do our other T-chart from our other reactant, sodium phosphate, to now sodium nitrate. So I start with 50 grams of that. Na3PO4. Am I moving too fast or are we doing okay? Okay. I wish the compounds weren't so long. Rewriting them over and over again is annoying. Okay, we've already got the molar mass of NaNO3. Mole ratio here is actually 3 to 1.
164.
Thank you.
I got 141.
I also got 164.
It's 141.
Did you do 3 sodiums?
I got 164.
Oh, I didn't do
Sodium.
I got 164.
Times 3.
Plus 31
Let's do this
plus
again.
64.
23 times 3.
Oh,
Nice.
I didn't, that's because I didn't write the 3, actually.
Okay, it changed.
All right, so when I multiply that out, what did we get for our mass of sodium nitrate?
77.6.
Yeah. Grams NaNO3. So here's what we need to identify. What's the maximum amount of sodium nitrate I could form?
31.
31.9. So then I could put it into my answer down here. Okay. This will not be a possible situation for me, right? I'm going to run out of ammonium nitrate before I'm allowed to make 77 grams of sodium nitrate. So that T-chart now becomes irrelevant. So if you want to cross it out so you don't end up writing that as one of your answers, I don't think that's a bad idea, right? Just do this or cross through that or something so you know like that T-chart no longer tells us any information, right? It did tell us what our limiting reactant was. So what is our limiting reactant?
NH4.
Good. NH4NO3. Okay, that is our limiting reactant. So that means every T-chart we do from here on out has to start with the limiting reactant. Okay. Can I go ahead and clear these 2 charts so I got room for the other ones?
Yeah.
Okay. Now we're going to look at the mass of our second product, which is ammonium phosphate.
You are right.
Ammonium phosphate. So now I know my limiting reactant is this one. So now I got to go to my other product. I'm going to start with 30 grams of ammonium nitrate. Oh, I shouldn't have erased the molar mass there. Did we say it was 80?
Yeah.
NH4NO3 to 1 mole of it. Our mole ratio now. Mole ratio here would be 1 to 3. And then moles of that would go on the bottom, grams would go on the top. Molar mass here will take a little bit of work for us.
149.
Whoa,
I think.
That,
That's right.
Let's think about it. Let's think about it.
I got 149 as well.
That it's probably right.
149 grams. So this is a mass of ammonium phosphate, NH4 3PO4.
I'm not right with that. That's too much work.
What'd you say?
144 or 144?
I got 149. So now I multiply across the whole top, divide by the whole bottom. 30 times 149 divided by 80 divided by 3. Yeah, 18.6. Is there a reason that we would need to go from sodium phosphate to that product? No, right? Sometimes people get into the rhythm of like doing charts and then we just like do extra ones, like for no reason, right? Once we identify the limiting reactant, all of our charts should start with that. And really the maximum you could do in a problem is 4. 2 to identify the limiting reactant, and then 1 for the other product, 1 for the other reactant. Okay, unless your equation has more than 4 terms, right? But usually that's not what we deal with. So, okay, so now that tells me the mass of this is 18.6. We've got one other problem left to do, and that's to find how much sodium phosphate, how much sodium phosphate is left over. So now we go from our limiting reactant here. That T-chart will tell us how much sodium phosphate is used, and then we do the subtraction from that. Okay, do you remember that part? It doesn't tell us how much is left over right away. It tells us if we use all 30 grams, how much of the other will be used. So let's walk through that, and we'll talk about that again.
We already have all the numbers for it.
Yeah, I think we did already find molar mass of...
Which is handy.
I'm sorry.
And what was that?
164.
Thank you. So now I'm going to run the math. 30 times 164 divided by 80 divided by 3. 20.5?
Yes.
Okay. Right. Okay, so let's talk about this. This is grams of Na3PO4. This chart, what it tells us is that if we use up all 30 grams of our limiting reactant, it would require that much of our other reactant to make that happen. Right? If I want to use all 30 grams of NH4NO3, I have to have 20.5 grams to mix with that to get my products. That's what that's telling me. That's not automatically telling me the leftover. This is telling me how much is used. That's really, really important. So if I wanted to find my excess reactant, I would have to go back and look at how much NH3PO4 did I start with. I started with 50 grams. I used 20.5 grams, which means left over would be 29.5 grams of Na3PO4 left over. Okay, how does that concept of excess reactant feel?
Good.
Pretty good? Okay, we've got to remember that the chart tells us what is used, then we subtract from how much of that particular thing we started with. Sometimes we'll try to do 30 grams minus 20.5, but that's mixing and matching our types of chemicals there, right? Our compounds. So we got to make sure we start with that particular compound.